So in this video we are going to discuss about Hermitian matrix. Okay, so this matrix has concepts associated with complex matrix, complex conjugate, and the transpose of the conjugate of a matrix. So the complex matrix, they are basically divided into two types: Hermitian matrix and skew Hermitian matrix. So first we'll take up the Hermitian matrix. Okay, so let us say we have a complex matrix A. Okay, A is a complex matrix. It means it has complex numbers as its elements, having both real and imaginary parts. So this matrix A, it will be called as Hermitian matrix if the transpose of the conjugate of matrix A, okay, the transpose of the conjugate of matrix A will give us the matrix A again. It means the transpose of the complex conjugate of matrix A will give us the same matrix A again. This is the definition of Hermitian matrix. Okay, I have already discussed about complex matrix, complex conjugate of a matrix, and the transpose of the conjugate of a matrix. So you please check out those videos first before you see this video. Okay, so this is the basic definition of a Hermitian matrix. The transpose of the complex conjugate of a matrix will give us the matrix A, the same matrix again. So let us see an example of a Hermitian matrix. Let us say we have a matrix A is equal to 1, 2 plus 3i, 3 plus I, 2 minus 3i, 2, 1 minus 2i, 3 minus I, 1 plus 2i, and 5. Okay, so this is the matrix A. Now we have to determine the complex conjugate of the matrix. Okay, so the complex conjugate, okay, let us calculate it here. The complex conjugate here, as there is less space, the complex conjugate of this matrix will be 1 is the real number, so it will stay as it is. For this 2 plus 3i, the real part will stay as it is, the imaginary part will be multiplied by minus 1. This 3 plus I, the real part will stay as it is, the imaginary part will be multiplied minus 1. Similarly, 2 minus 3i will become 2 plus 3i, 2 will stay as it is, 1 minus 2i will become 1 plus 2i, 3 minus I will become 3 plus I, 1 plus 2i will become 1 minus 2i, and 5 will stay as it is. So this is the conjugate of this matrix A. Now we will have to determine the transpose of the conjugate of this matrix. Okay, we have to determine its transpose, A conjugate transpose. So let us do it here side by side so that it will be easy to compare. The transpose of this matrix will be, the transpose of this matrix will be the interchange of the rows and columns, the matrix obtained by the interchanging of the rows and columns. The first row will become the first column here. The first row will become the first column. So 1, 2 minus 3i, 3 minus I. Second row will become the second column, 2 plus 3i, 2, 1 plus 2i. Third row will become the third column, 3 plus I, 1 minus 2i and 5. Now if we compare, this is the A conjugate transpose, there is no space here, so this is the A conjugate transpose. This matrix is transpose of the conjugate, A conjugate transpose. So now if we compare these two matrices, okay, A and A conjugate transpose, okay, A and A conjugate transpose, and we'll compare it element by element, we'll see both of them are equal. 1, 1, 2 plus 3i, 2 plus 3i, 3 plus I, 3 plus I, 2 minus 3i, 2 minus 3i, 2, 2, 1 minus 2i, 1 minus 2i, 3 minus I, 3 minus I here, 1 plus 2i, 1 plus 2i here, 5 and 5. So this satisfies this property. The transpose of the conjugate of the matrix gave us the same matrix back again, the original matrix. These two are equal. Okay, so it is a Hermitian matrix. This matrix A is an example of Hermitian matrix. Okay, because the transpose of the conjugate of this matrix gave us the same matrix back again. Okay, so this is all about Hermitian matrix.